Hello, today we'll talk about the memory allocation algorithms. Okay, so first fit, best fit, worst fit, next fit. This will be the points we'll be talking about today. First, first we'll take a quick introduction about what is the memory in general. Then we'll explain what each of these algorithms mean, and then we'll take an example for each of them. So one for first, one for best, one for worst, and one for next. Okay, so first, what is memory? Okay, your devices has some kind of two sizes. Okay, one is the storage, something like 32 or 64 gigabytes. Is where you keep your photos, your videos, the operating systems, the apps, and all of these things where they are stored persistently. So when you restart your phone, they're still there. They're not modified or changed or anything like that. Okay, and another thing is your memory, okay, your RAM, random access memory. This is where the apps and the operating system is loaded in order to work. So when you open your Facebook app, it is first read from the storage and loaded into memory for it to be working, okay? It does the same thing when you open a photo, okay? You click the photo is read from the storage, is moved onto the memory, and then it can be shown on the screen from the memory. And there are a lot of proportions for this size. Nowadays laptops have around 4 to 8 gigabytes. Your phone may have 3 or 4 or 2 or maybe 8 gigabytes of memory. Some time ago a normal computer have had something like a half gigabyte, so 500 megabytes of memory. Next, let's take an example with some memory. Okay, let's suppose we have a laptop with 4 gigabytes of memory. Here on the right side, you can see the laptop's memory. At the beginning, when the laptop is start up, there is no memory assigned, so the entire memory is free and it contains nothing. Next, the first thing that we need to load when we start up our laptop is operating system. Let it be Windows, Linux, Mac OS, I don't know, Android, iOS, whatever you want. And let's suppose our operating system has 1 gigabyte that needs to be loaded into the memory. What's the first thing? We load that gigabyte into the memory. Okay, we'll put it here. Now we're left with 3 gigabytes of free memory. We take the next step. We want to open a browser after the operating system is up. And that browser, let's suppose, will take us 500 gigabytes of megabytes, excuse me, of memory. So half of a gigabyte of memory. Now we have 1.5 gigabytes of memory used and 2.5 gigabytes of memory free. Next, let's say we open a game that will take us another 1.2 gigabytes of memory. So you can see 1 gigabyte, a half gigabyte, 1.2 gigabytes, and we're left with 1.3 or 3 gigabytes of memory. Next, let's suppose we minimize our game and close our browser. Okay, so the process for the browser is closed, as you can see here, and its memory is unassigned. So now this part of memory is free. Okay, so we have 1 gigabyte occupied, 0.5 free, 1.2 assigned, okay, so used, and another 1.3 free memory. Okay, next, let's suppose we now open Discord before returning to our game. So we'll have another process to load into our memory. Let's say it has 400 megabytes, so 0.4 gigabytes. Where could we store this? And now this is our question. Should we put it here or here? What's the better option? So for taking this decision, we have 4 algorithms. Okay, the first one is first fit. This means that we'll search for the first free slot and we'll take that. Okay, as you can see in this picture, we browse from the start of the memory and pick the first free slot. Best fit means we search for the smallest free slot where our process can fit. So we search for all the locations. We see that this is not enough, but we see that this is the smallest that still fits our memory requirement. Okay, worst fit is the opposite of the best fit, so it picks the biggest free slot. Okay, so as we can see here, this is the smallest, this is the middle one, and this is the biggest. We'll pick this one for these algorithm. Excuse me. Okay, and the last one is next fit. This is a bit tricky, but finally not that ugly. It's just like first fit, but we don't begin our search from the beginning every time. We begin it from our last allocation. So at the beginning, let's say we start from the start of the memory, and we pick this location to assign our memory. And then the next place we search for a free space when we need memory, it's from the last allocation, so from this point, and we find this point being the perfect one. And let's take each of them now. But before taking an example for each of them, let's first define our exercise. So let's say we have 4,000 bytes of space, so for about 4 kilobytes. And this is our memory at the initial point. So as you can see here, 300 bytes used, 550 free, 200 used, 720 free. Okay, and then we'll have to allocate some data, and these are our free slots. And then we'll have to allocate these blocks of memory: 400 bytes, 120 bytes, 600 bytes, and 300 bytes. And we'll take this allocation with every of those 4 algorithms. The first one, first fit. This means the requested data is put in the first available chunk that is big enough to fit it. So we'll browse from the beginning of the memory to the end and search for the first free slot where we can fit our memory, our block that we have to assign. Okay, first we have to assign this 400 byte slot. And we begin our search. Biscuits, never mind. Okay, we begin our search from this point. And we start searching and we find this first 550 free. It's the first one? Yes, it's the first one. Can it fit our block? Yes, it can fit our block. So we put it here. Now we have left 150 bytes free here, 720, and next you can see the rest. Next, we have to assign the next block of memory, 120 bytes. We begin our browsing from the beginning of the memory. We search for the first free slot. The first free slot is here. Can it fit our block? Yes, it can fit our block, so we'll put it here. Now we're left with 30 bytes free. Next, we take our 600 block and search for the first free slot. The first free slot is now 30 bytes. Can it fit our block? Nope. We'll go further. Now we reach this free block. It has 720. Can it fit our block? Yes, it can. So we'll put it here. Next, we take our 300 block and search for our first free slot. The first one is 30. Can it fit it? No. The next one is 120. Can we fit it? No. The next one is 780. Can we fit it? Yes. So we put it here. So we're done with the first fit algorithm. That's how it works. Now let's take a look at some other algorithm. Excuse my English. Okay, I have to practice it more. Okay, the next one is best fit. Here the point is not searching for the first place to fit it, but for the smallest chunk to fit it. Okay, and we take again our 400 bytes block. And we now must search for the smallest block to fit it. The smallest block is 140. Is it small? Is it big enough to fit it? Nope. We need to go to the next smallest, to the second smallest. The second smallest is this one, 470. Can we fit it here? Yes. So we'll do that. Now we're left here with 70 bytes. Next, we have to take our 120 block and search again for the smallest chunk available. 70 is enough? Not enough. 140 enough? Yes, it's enough, so we'll go for this one. Now we're left with 20 bytes free here. Next one, 600 Now we have to look again for the smallest. 20, not enough. 70, not enough. 550, not enough. 720, perfect. So we'll fit it here, and we're left with 123. Next block, 300. Now, 23 not enough, 70 not enough, 120 not enough. The next one is 550. It's enough, we can fit it here. Perfect. And we're done with best fit. So the point here is looking for the smallest ones to fit our block inside. Okay, if it's not small enough, of course, we skip it. So we search for the smallest where we can still fit our block. The next one is worst fit. So this is the opposite of biggest fit. We search for the biggest chunk and assign it there. Actually, this is never used in reality. It's just as an example to compare it with best fit and see how each of them, how one is better than other. And we take our 400 bytes block, and we look for the biggest chunk available, and that's 780. So we put it here. Next, 120. The biggest block left now is 720. We put it here. Okay, next block is 600. The biggest block available is 600, so it will fit perfectly there. The next one is 300. The biggest block left available is this one at the left, 550. So we'll put it here. And we're done with the worst fit. And as you can see, the free memory charts looks a bit different, and we'll take a comparison. I hope I said it well. We'll compare them at the end. Okay, the last one is next fit. This is just like first fit, but you start your search from the last assignation. And let's take an example. Okay, our cursor, our point of start for the search is here at the beginning. It's at the beginning of the memory at first. And we take our first block, which is 400, and we begin searching from where our point of start of browsing is. We start searching from here. And we find our first slot here, first free slot here. And we see it's big enough to fit it, so we'll fit it here. It's just like first fit. Okay, we've put it there, and now our cursor moves right here. And we have to search for a place for our next block, 120. But now we don't begin searching from the beginning of the memory, but we begin searching from here. And the first free slot where we can check is this one, 150. Can we fit it here? Yes, we'll fit it here and move our cursor to the right here. Now we'll take the next memory, 600. Next block we're going to allocate. And we'll search our memory from this point. Can we allocate it here? Nope. Can we allocate it here at 720? Yes. So we'll put it here and move our cursor right here just after our allocation. Now we take the next block, 300, and try to allocate it. The first possible position is this one, 120. Is it big enough? Nope. We go further, we find this block, this free block. Is it big enough? Yes. So perfect, we'll put it there and move our cursor in the following position. And this is all. Okay, for example, if we'd had a new block of memory of 100 right now, we couldn't fit it here, neither here, because our cursor is here. So we'll have to start our search from this point. So it would be just next to this 300 block. Also, one thing worth mentioning is that when our cursor reaches the end, it'll start again from the beginning of the memory. So for that step, it'll just look like first fit, only for that step. Okay, I hope you got the idea of how these things work. So now let's take a look at the comparison between all of them. So we'll be comparing the outcomes of each of them. You can see here are the results of our allocations for each algorithm. Okay, and you can see that with best fit we have very big green slots, and with worst fit or next fit and first fit we have a lot more free slots, but they're smaller. Why is this? Is because best fit tries to keep as much continuous free memory as possible, because when there will be a new process that needs, for example, 500 bytes, we can easily fit it in with best fit in this memory configuration, but we can't fit it with any other of these four. So this is why best fit is, as the name suggests, the best one of them, the best of them. Ha! Okay, so that's all. Thanks. If you'd like more exercises, we can try more exercises in the next videos.